Hello. So we are about to start section 4.1, which talks about inverse functions or finding the inverse of a function. And before we can do that, we need to talk a little bit about what it means for a function to be one-to-one, right? So remember that when you have a function, so for example, you have a function, you write f of x, right? And the function could be something very simple. How about just x plus 3, right? So this is a function because for every x, there's a y value, right? So for example, if x is 7, then y is 10, right? If x is -5, then y is -2, and so on, right? So for every x, there's only one y, right? If x is 7, y has to be 10. There's no choice, right? It can't be, any other number other than 10. Okay? Right? So that's what makes this a function, right? So what does it mean to be one-to-one? Well, a function, right? So f is one-to-one if every value of y has only one value of x. Every value of y, right? I should say, right, comes from only one value of x. Only one x value, right? Okay, so, right, so don't get confused with function. This doesn't mean it's a function, right? F is a function if every value of x has only one y value. Here it's the reverse. Every value of y comes from only one, right? One and only one x value comes from one and only one x value. All right. So what does that mean, right? So thinking about functions just as ordered pairs, right? So in this example here, we have a set of ordered pairs, say 5, 2, obviously very different from this function here. Well, actually, never mind. It is this function applied to, oh no, I'm sorry. It's not. It's, never mind. It has nothing to do with, right, so I'll call this example 0 up here, and this will be example 1, all right? Yeah, I got it backwards, right? So we have 5, 2, 0, 3, -1, 4, and 2, 7. Okay, so this is, well, right, I hope it's clear that this is a function because every x value has only one y value, right? In other words, we don't repeat the x's here. None of the x's repeat. And also, every y value, right? Every y value doesn't repeat. So it comes from one and only one x value, right? So this is one-to-one. Okay. So let's look at example 2, which are the set of these numbers, set of these ordered pairs, right? 8, 7, 2, 7, 0, 3, and -1, 4. Okay. So notice that this is a function because 8, 2, 0, -1, those are all different, right? None of the x's repeat. But if you notice, the y values repeat here. We have y equals 7, right? Y equals 7, but that comes from two different x values, right? It comes from both x equals 8 and x equals 2. So in other words, if this were f, right, f of 2 would be 7, and f of 8 would also be 7. Right? So you have a y value that comes from two different x values, right? So this function here, this is not 1 to 1. 1 to, I didn't spell it right, 1 to 1. Okay, so yes, not every function is 1 to 1, right? The first example is 1 to 1, and the second example is not 1 to 1. All right. Right. So let's go back to example 0 here, which I'll just copy down for convenience. So example 3, f of x, right? Because you're not going to see functions written this way as just a bunch of random ordered pairs. You're going to see it as an equation, like y equals x plus 3, right? Or f of x equals x plus 3. Right, it's an x. So is this 1 to 1? Well, right, if we have a y value here, and let me make this a little more clear, right? If this is equal to y, right, can we get that value of y from more than one x? Right, so let's just say y is 2, right? If y is 2, what x did that come from? In other words, right, when you have x plus 3 equals 2, what did x have to be? Right, so solve for x, right? So subtract 3 from both sides, and we get x equals 2 minus 3, which is negative 1. Right? But that's the only value of x we got here, right? So in other words, when x is negative 1, y is 2. And if y is 2, right, that can't happen for any other x, right? It's not going to happen for, 17. If x is 17, y is definitely not 2, right? That can't happen, right? Not for this function, right? Not for this example here. For example 3, that can't happen, right? So yeah, when y is 2, that only comes from x equals negative 1. So it turns out that this function here is also 1 to 1. Right? Because every y comes from only one value of x. Right? Okay. So let's jump to example 6 here. In fact, I'll just bring it down over here. So example 6, we have a function, I'll call it g of x, just because it's a different function here. And what was it? X squared minus 1. So g of x equals x squared minus 1. Right. Is g 1 to 1? So let's think about this, right? If x squared minus 1, if that's our y value, right, and we pick a y value, can that come from more than one value of x? Right? So what y should we pick here? Again, so let's keep it simple, right? How about 0? Right, so let's say y is 0, right? Suppose y is 0. Right. So if y is 0, what x did that come from? Right. So if we add 1 to both sides, we get x squared is 1. So that should be obvious, right? X equals 1, right? Because 1 squared is 1. 1 times 1 is 1, right? So that tells me that I have an ordered pair, right? 1, 0. So the question now is, for this to be 1 to 1, when y is 0, can this x be anything else? Can it be anything other than just 1? So remember, when you have x squared equals a number, the way to get rid of the square here is to take the square root. And if you remember, I hope you remember, that anytime you take the square root of both sides, you have two solutions, right? One positive, one negative. So there's actually two answers to to this equation, two solutions, right? There's x equals 1, which I think was obvious, right? And then there's another one, x equals negative 1. Okay. So when y is 0, that actually comes from two different values of x, one of them being 1, the other being negative 1. Make that a little bit clearer. Right? So we have y equals 0 coming from two different x's. And if you remember, just like in example 2 up here, when we had not y equals 0, but y equals 7, right, coming from two different x's, and we said because of that it's not 1 to 1. So the answer here is also a resounding no. G is not 1 to 1 because when y is 0, that comes from more than one x value, right? Right. So yes, so this is not 1 to 1. Okay? And to make that even more clear, let's graph these two functions here. I'm going to, again, do a very rough sketch here. You know, maybe I should bring up some graph paper, but right now I just want to get the basic idea here. So we'll graph these a little more careful next time, or at some point later. I think we'll do a more careful graph. So yeah, this should be good enough here, right? So this is my x-axis. This is my y-axis. Okay, so, right, so we want to graph the function, basically just the line y equals x plus 3, right? So 1, 2, 3, 4, 5, 6, 7, -1. Okay, so as you can see, this will be a little bit sloppy here, but, right, the graph is just a straight line. It's going to look like this, right? Okay, so this is f of x equals x plus 3. Okay, now, down here, right, so this was example 3. And then example 6, I know I skipped 4 and 5, but that's how this was labeled. And so now we can do, a very rough sketch of g of x, which is x squared minus 1. So, okay. Well, you remember x squared, right? That's just your parabola with the vertex at 0. So minus 1, x squared minus 1 just shifts it down 1 unit. So let's just transform this, shift it down 1 unit, and the graph looks a little sloppy, but something like this. Maybe I'll clean it up a little bit. Now, this is very hard to draw here. I keep missing. All right. All right, that's pretty close. Okay, so that's the graph of y equals x squared minus 1, right? So, right, so remember, this one here was 1 to 1, and then down here g of x was not. So this is 1 to 1. Oops. I'm running out down here. So this is 1 to 1. And this was not 1 to 1. And so remember what 1 to 1 means. It means for every value of y, or every value of y comes from one and only one value of x. So when you pick a value of y, what you're really doing is just drawing a you're drawing a horizontal line, right? So this horizontal line here might correspond to, I don't know, y equals 6, it looks like. So if y equals 6, notice that crosses the graph here at x equals 3, right? Because 3 plus 3 is 6. So 6. Right? And if I draw a different horizontal line. If I draw a different horizontal line, let's suppose I draw this one here when y is 1. If y equals 1, that crosses the line at -2, because -2 plus 3 is +1, right? So any horizontal line that you draw here, right, any horizontal line will cross the graph at most once. Okay. What about down here for this function, x squared minus 1? So if I pick any horizontal line, I'm just going to pick y equals 3. So 1, 2, 3, yep, right around here. So here's this horizontal line. This is y equals 3. And what x value or values does that come from? Well, it should, so this should, oh no, I think this is right. This should come from x equals 2. But it also comes from x equals -2, right? So this horizontal line here, this y equals 3, crosses the graph once here at the point 2, 3, and once over here at the point -2, 3, right? So because y is 3 and x has two different values, one positive, one negative, that means it's not 1-to-1, right? Because it doesn't come from only one value, it comes from two values, right? So that's the idea for being 1-to-1, right? And so in terms of the graph, you get something called the horizontal line test, right here, which says the following. A function is 1-to-1, right, if no horizontal line intersects, right, or crosses the graph more than once. So here we had the graph of this yellow line, right, y equals x plus 3, and we have no horizontal line crossing more than once. In fact, all the horizontal lines cross just once. So that's why it's 1-to-1. On the other hand, if you have any horizontal line that crosses the graph more than once, then that graph does not represent a 1-to-1 function. So here, for this function here, any horizontal line that crosses more than once, such as y equals 3, will not be 1-to-1, right? So because this crosses twice, which is more than once, right, it's not 1-to-1. Okay, so I hope that at least explains somewhat what 1-to-1 means. 1-to-1 just means every y comes from only one x, right? So don't get that mixed up with every x has only one y. That's going to happen for any function, right? For any function f. Okay. In fact, that's the definition of a function, that for every value of x, you only have one value of y. But it's 1-to-1 if every value of y has only one value of x, right? Right. In some sense, right, it's a function if every vertical line crosses the graph, right? So if you have a vertical line crossing only once, then it's a function, right? That's the vertical line test. So a vertical line test is to see if you have a function. The horizontal line test tests if it's 1-to-1, if the function is 1-to-1. Right? And not to confuse you too much, but you can be 1-to-1 and not a function, right? So you can look at this example 3 here and see that you don't have a function, but it is 1-to-1. So it's a 1-to-1 relation. But when we say something is 1-to-1, we usually mean it's also a function. At least for this section and for this chapter, I think that's all we're gonna talk about there. So, all right. So again, make sure you understand the concept of 1-to-1. Right? 1-to-1 just means every y has only one x. Right? Okay. So why do we care so much about 1-to-1 functions, or what, you know, when why a function should be 1-to-1? So if you have a 1-to-1 function, you can define what's called the inverse of that function. Okay. So before we do this, before we get to the actual definition here, let's just look at an example. Right? So we have a function f of x, and let's go back to, right, just x plus 3. Right? And we already said that this is 1 to 1, right? And since it's 1 to 1, we can find what's called the inverse, right? So we want to find the inverse of f, right? So the inverse of this function, f of x, is another function. So it's another function, which I'll call g of x, at least for now. We'll give it a different symbol later, but it's just some other function, g of x. And that function, in some sense, right, so this is very informal here, but it undoes the original function f of x, right? So what do I mean by g of x undoes this function? Well, right, what's sort of the opposite? And again, we should use the word inverse instead of opposite, but in this example here, they're both appropriate, right? So if f of x takes x and adds 3, then g of x should do the opposite. What's the opposite of adding 3? Well, how about subtracting 3? Right? So this should be the inverse in the following sense, right? If I take any value of x, let's say x equals 5, right? And I apply f to that value, 5, what does f do to x? Well, it just adds 3, right? It adds 3 to any x as the input, right? So you take our number 5, you plug it into the function f, and f just adds 3 to that, right? So 5 plus 3 is 8. So that means the output, the y, is equal to 8, right? Okay. Now, suppose we take this 8, that's the y value for f, right? And now I plug that into the g function, right? G being x minus 3, right? So now g takes this 8, right, as the input, and it just subtracts 3 from it. And 8 minus 3 is just 5. Right? So you see what we did here, this whole process, right? You take 5 goes in, and 5 comes out, right? You get back your original x. This was the original x, right? X was originally 5. You apply f to that number 5, and you get a new number, 8. And then you reverse it. Then you take 8, you plug it into the inverse, and you get back 5. It spits out 5, right? So what we did here is a composition, right? We took g composed with f of the number 5, right? That's just g of f of 5. And we just got back 5, right? We just got back 5. So, yeah, the inverse of this function, f of x equals x plus 3, the inverse of that just subtracts 3, right? And you get back your original number, in this case 5, but it didn't have to be 5, right? You can pick any number here, right? So yeah, if you pick any x, let's do that again. You pick any x, you plug that into f, and out comes, well, not the original x, but 3 more than that, right? X plus 3. Now, if you put that into g, what does g do to this whole thing? It just subtracts 3. So you have x plus 3 and then minus 3. Well, 3 minus 3 is 0, so you just get x plus 0, which is the original x. The same thing you got that you put in, right? So in other words, the input becomes the same thing as the output. Right? So in other words, if I apply g to f of x, I just get back x, right? And it may not be clear here, but it works the other way around as well. If I take f and I apply that to g of x, I also just get back x. Okay, so if both of these are true, then we say that g is the inverse, right? It's the thing that undoes f, right? Is the inverse of f. Right. And what we're going to do then is, instead of writing it as g, we're going to write it as f with this little -1 of x. Now be careful. Yes, this is a -1, and it looks like it's the exponent, right? After all, if I just write, hang on. Right. If I just write 3 to the -1, you would recognize that immediately as just 1 over 3, right? If -1 is the exponent here. However, remember what f is. F is just the name of the function. It's not a number. So this -1 here is not an exponent. Okay, right? In other words, this is not 1 over f of x. Okay, you cannot just take the reciprocal. The inverse is not the same as the reciprocal, right? So I'll write it down. Inverse is not the same as reciprocal. Well, in general, I should say, right? In some cases, it might be the reciprocal. In very special cases, maybe, but definitely not most of the time. Not in general, right? Okay, so yeah, so be careful, because a lot of people read this as f to the -1. You should not do that, right? If you constantly say, f to the -1, you're gonna get a lot of stuff wrong, right? It's a very bad habit, right? So when you see this symbol here, the way to read this is you should just say, right, the inverse of f. Or even more concisely, just say f inverse, right? F inverse, right? The inverse of f. Not f to the -1. Not 1 over f of x. Okay. All right. Yes. So just changing the g to your f inverse here, right? Again, don't get confused with exponents here. This is not an exponent, right? But now we can say that the inverse function, if you take the inverse of the original function, you just get back x, right? And if you take f of the inverse function, right, if you compose f with f inverse, you still just get back the original x, right? Right. Yeah, in fact, let's come back to this second thing here, because we didn't go over this. We just established this. So we're going to do the same thing down here. We're going to take, let's take a different x. How about x is equal to 12? Right? So suppose x is 12, right? But now I'm going to take that 12 and plug it into g first. So what does g do to 12? Well, what's g of 12? So g, that was way up here, right? G was x minus 3. So, right, so this will be 12 minus 3, which is 9, right? So, yep, if the input is 12, the output is 9. 12 minus 3 is 9, right? Now let's take that 9 and plug it into the function f. So what does f do to x? It's way up here. It's x plus 3, right? So remember, f of x is just x plus 3. In this case, my x is the number 9. So what does f do to 9? It adds 3. And 9 plus 3 is 12. So naturally, f spits out the number 12, which, if you remember, that was the original x. So you're still just getting back x here, right? Makes sense? So yeah, in that sense, F inverse, right, undoes the original F. So here, my F, well, let's write this. Yeah, let's just write this down here again, just to make it, hopefully make it clear at this point. If my F of x takes x and adds 3, then that means the inverse, F inverse, right, which I formerly called g of x, now I'm calling it F inverse of x. Well, what's the opposite of adding 3? Subtracting 3, right? So, yeah, the inverse just undoes the original function, right? And I know that's not very precise. We'll make it a little more precise later, but that's the idea, right? It undoes the original function. It just gives you back your original x, whatever x was, right? Whether x was 5, or in this case, x is 12, right? You just get back the original x that you started with, right? So that's what these tell us here. Right. So it might help to look at another example. So what did I call this? Example 1. So let's do example 2. Yes. Example 2. Suppose we just want to find the inverse of, so f of x is, again, let's start simple. How about 2 times x? Okay, so the question is, we're looking for another function, g of x, or better yet, f inverse of x, that undoes this function, right? So what does f do to x? So f takes x as the input, and the output is just, well, double that, right? So, for example, if the input is 5, well, I did 5 already. Let's pick a different one. I don't know, how about 8? Or 7. Okay, 7. 7's a good one. I mean, it doesn't matter, right? I'm just picking these out of a hat here. So what does f do to 7? Well, it doubles it, right? 2 times 7 is 14. Okay. Now, how do we get back to 7? What do we have to do to 14 to get back to 7? Well, you have to divide it by 2, right? You got to cut it in half, right? So you're just going to take half of the input, 14. And so that's the answer, right? What happens to, right, how do you get back to x here? You take 2x, and if you cut it in half, if you divide by 2, you get back x. So the inverse function, instead of multiplying by 2, you divide by 2, or you multiply by 1/2, right? So whether you write it as 1/2 times x, or x divided by 2, doesn't matter to me, as long as you realize that sort of the opposite of multiplying by 2 is dividing by 2. Well, okay, I take that back. It's not the opposite, right? It's the inverse. The inverse of multiplying by 2 is dividing by 2, right? Right? So let's check that, right? Let's check that in the following way, right? If I take f inverse of f of x, I should just get back x, right? Well, let's see. Do we do that, right? What does f inverse do to x? It cuts it in half. So what does it do to f of x? It takes f of x and divides by 2, right? Now, remember what f of x is. F of x is just 2 times x, right? But this is 2 times x divided by 2. So 2 divided by 2 is 1, right? And so, sure enough, this is just 1 times x. You just get back your original x, right? Let's go the other way. Let's take f of f inverse, right? So what does f do to x? It doubles it. So what does it do to f inverse of x? It doubles it, right? Now, what's f inverse of x? Yeah, I was just going to do parentheses here. There's the 2. f inverse of x is this, right? It's just 1/2 x, right? Or x divided by 2. Well, remember, you can multiply in any order. You can do 2 times 1/2 times x, or 2 divided by 2 times x. 2 divided by 2 is 1. 1 times x is just x. So sure enough, you just get back your original x, right? So yeah, in other words, we confirm that the definition of the inverse holds here, right? The definition is that the inverse of the original function just cancel, and you just get back x, right? They undo each other. And if you take f of the inverse, again, they just cancel out in the following way. You just get back the original x, and we showed that here, right? So yeah, so that's, right, the inverse of 2 times x is just x divided by 2. Okay, so we should do one more example, because in these examples here, we kind of just sort of guessed the answer. But now we're going to do, we're going to show you the way to actually find the inverse in general when it's not so obvious. Okay, so I just had to get rid of all that clutter. Yeah, so how do you, in general, how do you find the inverse of a given function? So that's going to be way down here. Right. So to find the inverse, f inverse, right, not f to the -1, don't even think that. It's basically just 3 steps here. Right? You write down the original function, and you change your f of x to y. Right? And then you interchange or switch the x's and y's, and then you solve for y. Okay? So let's do another example. Well, I guess we're up to example 3. Suppose we want to find the inverse, right? F inverse, right? For the function f of x, and I'm going to make my f of x equal to 4x minus 5. So 4x minus 5. Well, you know what? I changed my mind. How about 4x minus 8? I mean, it doesn't matter, but okay. So 4x minus 8, right? So, so what are we looking for? We're looking for f inverse, right? Or g of x, if you like, but f inverse is the way to write the inverse. So what function undoes this function here? What undoes the function 4x minus 8? And so probably not as obvious, right? Because you're doing 2 things, right? You're multiplying by 4, and then you're subtracting 8. All right? So in some sense, yeah, you're going to divide by 4, you're going to add 8, but you got to be careful because you got to do it in the right order, right? So, so to make sure we do this in the right order, the first step we're going to do here, right, step 1, says to write y equals 4x minus 8. I should do this in a different color here. So y equals 4x minus 8. Right? So yeah, in other words, you just replace the f of x with y, and it really means the same thing, right? If I change f of x to y, it's the same thing, right? Okay, right, and this is a 4, not a y. Okay, so step 2, I'm sorry, I used different colors here. So step 2, now we have to interchange x and y, right? Switch them. So the y now becomes an x, right? And the x now becomes your y. Okay. So yeah, the process of finding the inverse is effectively just switching the x's and y's here, right? And so in step 2, this is already the inverse, but we want to write it as a function, right? In other words, we want to solve for y here, right? So how do we solve for y? Well, let's start by just switching sides. Let's make it 4y minus 8 equals x. Right? You can always just switch sides. If this equals this, then this equals this, right? All right, so what next? Well, we should add 8 to both sides first. So add 8 to both sides. And when you do that, you still have 4y on the left plus 0, right, equals x plus 8 on the right. All right. Now, this is 4 times y. If we want to solve for y, we have to divide by 4, right? So divide both sides by 4, right? And so the 4 divided by 4 is 1. The 4's cancel. And I think that's it, right? So now we have y equals x plus 8, right? All divided by 4. The whole thing divided by 4. Which you can leave like that, or you can write it as, right, x divided by 4 plus 8 divided by 4. And of course, 8 divided by 4 is 2. So this is just x over 4 plus 2. Or you can write 1/4 times x plus 2. Right. So that's it. That is our inverse function. And just let me write the answer up here, right? 1/4 times x plus 2. Or if you want to leave it, right, the original way here, I didn't mean to cross out the 4, right? If you want to write it this way, that's fine too. So x plus 8 all over 4. So, yeah, I'm not going to be picky about that. I guess because this is a linear function, maybe we should write it as a linear function, mx plus b, if you will. But it's the same thing, right? So that should be the inverse of this function. And so it's just 3 simple steps, right? So change f of x to y, switch the x's and y's, right? Switch the x's and y's around, and then solve for y. Okay. So I hope that helps, you know, finding the inverse of a function. And well, this might have been a, you know, pretty routine example. Let's do a slightly more difficult one. Yep, so example 4. Let's do here. Right. We're still finding the inverse, right? Find the inverse of f of x equals, let's do 2 plus the cube root of x minus 7. X minus 7, yeah. So, I don't think I need that. Okay. A little clumsy there, sorry. All right, so again, this is definitely a more complicated function, but we're still going to be able to find the inverse just by doing these 3 things here. So let's start with step 1. Step 1 is to change f of x to y. Oh, I hate leaving all that space here. So let me write it over here, right? So instead of f of x, it's now y, but that still equals the same thing, right? 2 plus the cube root of x minus 7. Okay, so far? All right. Step 2. Step 2. Interchange or switch the x's and y's. Everywhere you see a y, right, that becomes an x. Everything else stays the same, right? And everywhere you see an x, change that to a y. Again, leaving everything else the same. Right, so this is still the cube root here, right? Okay, right, so far so good. No problem there. And step 3 is usually the hard part, right? Because it's a little bit of algebra. So now we have to solve for this y here, right? Okay, so let's get the y on the left, right? So let's just switch sides here. We have 2 plus the cube root of y minus 7, and that just equals x. Okay, so you can see in some sense we have to sort of undo the cube root. But before we do that, why don't we just take away 2 from both sides? And so now we've isolated the cube root of y minus 7, and that's just the same as x minus 2, right? So yeah, remember we're solving for y here, right? So now what comes next? Well, if you're thinking add 7, be careful. The negative 7 is underneath the cube root, right? So before we can get rid of this negative 7 here, we got to undo the cube, the cube root. And how do you undo the cube root? Right? You cube it. You raise it to the power 3. Now, if I do that to the left side, I got to do the exact same thing to the right side. Raise both sides to the power 3. Right? So in some sense, that undoes the cube root, right? Right? So when you undo the cube root, you just are left with y minus 7. And on the right side, we no longer have x minus 2. We have x minus 2 to the power 3. All right? Now we're almost done, right? Now you can actually just add 7 to both sides, right? Now you add the 7 to both sides. And, right, negative 7 plus 7 is 0. So you just get y equals x minus 2 cubed plus 7. Right? And that's the inverse function, right? In fact, we can write it f inverse of x is equal to, x minus 2 in parentheses, right? All raised to the power 3 plus 7. And that's it. That's the inverse. So I hope that helps, right? So it's a little more complicated. Oh, and again, feel free to leave it like this. Obviously, some of you might be tempted to, expand this out here. X minus 2 times x minus 2 times x minus 2, and then plus 7. That's a lot of work. It's doable. And in fact, let's go ahead and do it. If you multiply x minus 2 times x minus 2, you get x squared minus 2x minus 2x minus 4x. And then negative 2 times negative 2 is positive 4. And then you got to multiply by plus 7. Then you got to multiply by another x minus 2, right? So this becomes a lot more tedious. And let's see what we get. We get x squared times x, which is x cubed, right? So same x cubed there. Then we have minus 2x squared minus 4x squared, which is minus 6x squared. And then we have 4x plus 8x, which I think is 12x. And then 4 times negative 2 is negative 8. Right? And finally, plus 7. So this is x cubed minus 6x squared plus 12x minus 1. So, you could have done this, but honestly, just feel free to leave it like this. It's the same thing. Right? So in this case, I really don't see a need to multiply all this out here. Unless they specifically say expand it out as a polynomial in standard form, but not necessary here, right? Okay, yeah, let's keep going. Let's do another one because, as I say, these two examples, right? The first one I think is fairly routine. The second one's a little bit more algebra, and the third one's going to be even more algebra here. So, so let's do that. What are we up to? Example 5? Yeah, example 5, at least in this section here. All right, so let's find the inverse of, so let's make it f of, okay, f of x is equal to, so I want to do, right, I guess I'll make it as hard as possible here. So 2x plus 8 all over x minus 2. Okay. So, yes, this is a function and we want to find its inverse, right? In other words, we want to find f inverse of x. So, step 1, as always, change f of x to y. Right. Step 2, right, interchange x and y, so the y becomes an x, and this x in the numerator becomes a y. And likewise, this x in the denominator, that also becomes a y, right? Change all the x's to y's and all the y's to x's. Okay? Okay. Now comes the hard part. Now we have to solve this for y, right? And this is something you've done already. This is something you did way back in your intermediate algebra class, right? You're basically just solving a rational equation, right? So so we can think of this as a fraction on the left, and notice that it's also a fraction on the right. Fraction on the right and fraction on the left. So the easiest thing to do here is just cross multiply, right? Multiply x times y minus 2. And then 1 times, right, so that's going to equal 1 times 2y plus 8. Okay, so yeah, just cross multiply, and you should get this. Okay. Remember, we're not solving for x, right? So don't just divide by the y minus 2. You'll end up back where you started. We want to solve for y, right? So that looks kind of tricky here because there's y's on both sides. Ultimately, we're going to bring all the y's to the left. Before we do that, let's just distribute the x here, right? So this is x times y minus 2 times x. And then 1 times 2y is 2y. 1 times 8 is still 8. Okay. What's next? Well, as I say, we can't have y on the left and on the right. So why don't we subtract 2y from both sides here? And that has the effect, right? This is going to be x times y minus 2 times y. And then minus 2x equals 0 plus 8, which is 8. Right? So I managed to bring all the y's on the left side here. Make sense? All right. Well, again, you want to isolate y. Remember, our goal is to get y equals. Y equals what, right? So we're not done. We still have to solve for y. So we don't need this minus 2x on the left because there's no y's here. We can just add that to both sides, right? So add that to both sides, and now we still have x times y on the left minus the 2 times y, and then we cancel these. Negative 2x plus 2y is 0. And on the right side, we have 8 plus 2x, which I hope you would agree is the same as, right, 2x plus 8. It doesn't matter what order you write it in, so 2x plus 8. Okay. And so now kind of the tricky part here, because you want to isolate the y. So you want to get the x to the right, but you can't, you might think you just divide by x, right? But that's a bad idea here, because you can't just divide this by x, right? You have to divide the whole thing by x, right? And if you do that, you're still going to have minus 2y over x, right? So unfortunately, that's not going to work. It's a good idea, but it doesn't get you what you want here. All right. Notice that for both of these terms here, they both contain a y, a factor of y. Right? So that's my common factor. That's my greatest common factor, which means I can factor out the y here. So when you factor out the y, you're left with x minus 2. Okay. And so that's still equal to 2x plus 8. Right? Now we're almost done. Right? Now we have y times x minus 2. So to solve for y, we do the opposite of multiplying by x minus 2. We divide by x minus 2. Again, on both sides. Okay. And so we end up canceling the x minus 2 here. And I think we're basically done. We have y equals, right, 2x plus 8 over x minus 2. So there's our inverse. Right now, just write it as f inverse of x. Sorry, it's not a minus sign. That's just a fraction. 2x plus 8 over x minus 2. So that's our answer, right? So f inverse of x is just 2x plus 8, over x minus 2. Now, you might think, wow, we found the inverse and we got back the original function. That wasn't intentional, of course, but look, that can happen. That can happen. The inverse doesn't have to be different from the original function, although it usually is. If you look back at the previous two examples, they were both very different from the original function, right? This had a cube root, this had a cube, right? This is 4 times x, this is 1/4 times x, right? So usually you don't get the same function. But here you do, okay? In this example, you just happen to get back the original function. That was clearly not at all intentional, but that is a possibility, right? In fact, I'll give you another another example where the inverse is the same as the original function. Okay, so I'll call this example 6. Right? And it's one that you know, if I ask you find a function that's the same as the inverse, right? Can you find a function that's the same as the inverse? Well, here's one example, right? But there's an even easier one. Right? How about just f of x equals x? Right? So if f of x equals x, just find the inverse, right? Change f of x to y, switch the x's and y's, and now solve for y. Well, if x equals y, y equals x. So that's the inverse, right? So, yep, if f of x equals x, the inverse is also just x, right? So what function undoes the identity function? What function undoes x? Just the same thing, right? So, yeah. So that's, again, this doesn't happen very often, right? So this is pretty rare, but it happened here and it happened here. But don't count on that happening very, very much. Okay. Okay, so I think we have to do one more example, maybe two, but we'll do at least one more example here. And again, I'm going to just get rid of all the clutter here. So once I get rid of all this clutter, we'll do, I guess it'll be example 7. Okay, so yeah, one more example. This will be example 7. Find the inverse. Of the function f of x is equal to, let's do x squared minus 9. Sorry. Let's just do x squared minus 5. Close enough. Okay. All right. So let's go through the same process here, right? So the first step is to change f of x to y. So y equals x squared minus 5. Right. Step 2, switch the x's and y's, right? Or interchange them, either way. And you get this, x equals y squared minus 5, right? And step 3, solve for y, right? So if y squared minus 5 equals x, what's y? Well, right, before I try to get rid of the exponent here, let's add 5 to both sides. Plus 5 on both sides. And now we just get y squared is equal to x plus 5. Right, and now we just have to get rid of the exponent of 2. So what undoes squaring something? Well, how about taking the square root, right? That undoes the square. So if you take the square root of the left, you get the square root of the right. And I hope you're not forgetting the all-important plus or minus. Anytime you take the square root of both sides, there's always one positive and one negative. So y is going to be plus or minus the square root of x plus 5. But hang on, right? That's not a function. This is not a function. Why? So remember what a function is, right? A function is something that, well, you can write, f of x for, or in this case, f inverse of x, but we can't do that here because it's not a function. Remember, a function is every x has only one y. So if I pick an x, and I'm just going to pick 4 for a nice number, suppose x is 4, what's y going to be? Well, it's going to be plus or minus the square root of 4 plus 5, which is 9. And the square root of 9 is 3. So I get y equals plus or minus 3. But remember, that's not a function. If x is 4 and y is 3, well, there wouldn't be anything wrong with that. But we also get x equals 4, y equals negative 3. And yeah, that can't happen for a function. You can't have the same x with more than one y. Right? You can have the same y with more than one x, but not the same x with more than one y. Okay. So what's the answer? What is the inverse here? Well, the inverse is, even though it's not a function, you can write it as, as y squared equals x plus 5. Plus 5, sorry. But just keep in mind that the inverse is not a function here. Right. So what went wrong? Well, what went wrong is that we didn't check that this is 1-to-1. And in fact, this is not 1-to-1. Okay, so remember that business about 1-to-1 at the very beginning? Well, now that's important, right? Because if you don't have a 1-to-1 function, you're not going to get an inverse function. You get an inverse, just not an inverse function. Okay, so this is why it's important to be 1-to-1. Up until now, all the previous examples were 1-to-1, right? And that's why when we found the inverse, we can write it as, f inverse of x. Here we cannot do that. Okay. All right. So if it's not clear, I'm going to try to make it clear by drawing the graphs here, right? So bear with me. I'll try to make this as vertical as possible here. And that's as horizontal as possible. So this is my x-axis. This will be my y-axis. Forgive me. Right, and we can draw the original function. I'm going to exaggerate a little bit here. Well, not much. Right. So the original function, right? X squared minus 5. It's obviously just x squared shifted down 5 units. So, oops, missed that. So connect the dots. And then the same thing here. Okay. Not great, but close enough, right? So again, this is just the graph of the original function, y equals x squared minus 5. Shifted down 5 units, right? Right. So what if we tried to graph the inverse, this thing here? So here's what that's going to look like, right? Obviously, if y is 0, then x is going to be 5, which is way over here. I'm sorry. If y is 0, x has to be negative 5. That's way over here, right? Right. And then you can pick more points. If y happens to be 1, then x is negative 4, and so on. So you connect the dots and the graph will look something like this. That's a little bit cleaner. There we go, right? And now you can see why this is not a function, right? It fails the vertical line test. You have a vertical line. Well, let me try that again. You have a vertical line here, which crosses more than once. So yeah, not a function. Not a function, right? And that's because the original graph, the green one here, is not 1-to-1. Remember, 1-to-1 means it has to satisfy the horizontal line tests. Well, the horizontal line, something like this, can only cross once, And it doesn't. It crosses twice. So that's why the original function is not 1 to 1. When the original function is not 1 to 1, the inverse will not be a function. Right? And that's what's going on here. Okay. So yeah, this is why it's important when you're finding the inverse to make sure that before you do anything else, make sure it's 1 to 1. Otherwise, the inverse might not be a function. And that's what happened here. Now, what we could do is, by changing the domain of this, we could make it 1 to 1, right? And so let's take the same example here. And I'm just going to move it way down over here. So example 8. So we have the same function, x squared minus 5. But let's say instead of the domain being all real numbers, right, then naturally it's all real numbers, but I'm going to restrict it. I'm going to make the domain from 0 to infinity, right? In other words, x is greater than or equal to 0. So by doing that, now we have the graph will look something like this. Okay, that's better. Sorry for taking a while. I want to set this up as carefully as possible here. Of course, I could just bring up a sheet of graph paper, and that's probably what I should have done, but I'm going to do this strictly by hand here. All right, so, so x squared minus 5, right? So shifted down 5. But now, right, we're only going to plot where x is positive. So that's right about here. Yep. Okay. Right. So in other words, it's just half of the parabola here. It's the right half of it. Right. So now there's no problem, right? This is 1 to 1. If you have a horizontal line, it's only going to cross once. No matter what horizontal line you draw, you're only going to cross the graph once. Right. So you can go through the same process that we did here, right? And on the last step, when we had y squared equals, right, x plus 5, now when you take the square root of both sides, you take the square root of both sides, right, there's no minus sign because y has to be positive here, right? In other words, the graph, right, will now be a function. It's just going to be positive square root of x plus 5. And the graph of that should look like this. Okay, so this is the graph of the inverse function, and this is the graph of the original function. And you can see that, right, that this is now a function because there's no minus sign here, as there used to be. Okay. Right. In fact, I probably should have mentioned this already, but what happens when you talk about the domain and range? Remember, the domain are the x values and the range are the y values. So let's look at the original function f, right? Let's find the domain and the range. Well, the domain I gave you. The domain is this, right? It's all x values greater than or equal to 0. So from 0 to infinity. What about the range? Well, the range for the y values, we're starting, the lowest y value here is -5, and then it just keeps going up. Right? So the range is from -5 to infinity. Right? In other words, y is going to be bigger than or equal to -5. -5 being the lowest point for y. Okay. Now, what happens when we look at the inverse function? Well, find the domain of this. Well, remember when you're taking the square root, you better make sure that you're not getting any imaginary numbers. And so you want to make sure you're not taking the square root of negative numbers. You want to take the square root of positive numbers, right? Or 0. Square root of 0 is fine. Square root of 0 is 0, right? So when you solve this inequality, you get x is greater than or equal to -5. Right? So that's the domain, from -5 to infinity. Right? And what's the range? Well, the range of the y values. Look at the graph, right? The smallest y value here is y equals 0, and it just goes up from there, right? So the range goes from 0 to infinity. Okay, so notice something. The domain of the inverse is the same as the original function, right? And likewise, the range of the range of the inverse is the domain of the original function. The domain of the inverse, however, is the range of the original function, right? So in other words, the domains and ranges just got switched, which probably makes sense in light of, remember, what's the second step here? You switch the x's and y's. So if you're switching x and y, you can be sure you're switching the domain and range, right? Because the domain, remember, those are the x's, and the range, and the range are the y's. So if you switch x and y, you better switch the domain and range as well. Okay, so yeah, and that happens for all, anytime you find the inverse, you're switching the domain and range, right? Because you're switching the x's and y's. You're interchanging x and y, right? Okay. So, so I hope that helps. Again, this example was a little trickier simply because this wasn't one-to-one to begin with. And if it's not one-to-one, then your inverse will not be a function, right? But if it is one-to-one, as it was in, example 5, 6, 5, and 6, then those inverses were also functions, right? But by just altering the domain, you can change, right, a 2-to-1 function into a 1-to-1 function, right? So f was 2-to-1 because every horizontal line crossed twice. And here, every horizontal line, right, just crosses once, right? And so for the inverse, it's the opposite. Every vertical line crosses just once, which makes it a function. Right? So I hope that helps.